Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you. Most people have heard of phytoestrogens, but did you know there are beneficial phytoandrogens that mimic and support testosterone and more? The top source of these is pine pollen. If you're looking for 100% natural hormonal support for men and women, you've got to try this. Right now, Lost Empire Herbs' best-selling pine pollen is available for 1 penny plus shipping and handling. Go to geniuspollen.com to find out more and grab yourself a bag today. No hidden charges, no trial offer, no shenanigans. Just a low-cost way to try Lost Empire Herbs' top product for next to nothing.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Zoie Diana. She's a scientist at the Marine Lab at Duke University. She's a Ph.D. candidate there. So we're going to talk about her research interests around plastic pollution and management. So, Zoie, thank you for coming.
Yeah, thank you so much for having me, Richard.
Yeah, if you would, tell me about your background. What got you interested in, microplastics and plastic waste?
Yeah, so my background, I originally, during my master's, I wasn't studying plastic pollution. I got into this during the PhD, but originally I was studying actually barnacle adhesive and some of the anti-fouling coatings that are used to keep barnacles off of boats. So I've always been interested in sort of these interactions between how humans are trying to, meet their ends in terms of maintaining their boats for anti-fouling coatings, and then how that affects the ocean and the animals that live there. So originally that's what I was doing for my master's. I wanted to continue doing research, and the opportunity came up to study plastics, and I was like, yes, this is a fascinating topic and something I had always been interested in. I'm from Pittsburgh, Pennsylvania, so a landlocked area, but I've always been interested in the marine environment and actually wrote an essay on the Great Pacific Garbage Patch when I was like a senior in high school. So
Cool.
It's always, it came back around, and I finally got my time, I'd say.
Have you been able to visit the garbage patch, or is it like really far away?
I haven't had a chance to visit it. When I tell you a little bit more about my work, I'm not in the field as much as I would like to be, but, and there was also some COVID cancellations for some field work I was supposed to do as well. Yeah, no, it's okay.
It'd be cool if they had someone was a tour guide and you paid them and they took you out to the garbage patch and you had to collect like a few pieces of plastic from there, to bring back, let's say, as like souvenirs or something, and it might help maybe monetize a little bit of the cleanup if someone did that.
So I believe Five Gyres, the nonprofit, does do trips out to, whether that be the garbage patch, but also other areas as well, that folks can join, whether you're, a scientist or an artist. I'm not affiliated with Five Gyres, so best to reach out to them. But there are some groups who are doing trips like that. And I agree. It's a great way out as well, just to spread like the education and awareness about marine plastic pollution. But something about the Great Garbage Patch, just since it came up, oftentimes, in the media, we see these like these images of large tires and plastic bottles everywhere floating around, but a lot of the plastic that's actually out there in the Great Pacific Garbage Patch is microplastics, from what the science is saying. So these small pieces of plastic less than 5 millimeters in size that you wouldn't actually see, though, if you went out, unless you, of course, had the gear in order to collect microplastics. So just an interesting tidbit. Yeah.
Do you think there might be an interface between the barnacle work and this? It brings to mind an interesting question, like in the marine environment, does any of this plastic garbage get barnacles on it?
Yeah, that's a great
Biofilms.
question. We're looking at some settling of different animals on plastic at the Duke Marine Lab. These results haven't been published yet, and it's just sort of a preliminary study. I don't believe we were seeing barnacles out there, but something that is slightly tangential but related to your point is that a lot of the commercial hull coatings on boats, so that's going to be the portion above water, as well as the anti-fouling paints, have a large polymer component. And we're finding out that paints are actually one of the largest contributors to microplastic pollution in oceans and waterways, whether that be paints from boats, but as well like architectural paints, road paints, so on, are actually contributing to microplastics. So in some ways, there's already barnacles on paint because the anti-fouling coatings themselves are actually polymers. They oftentimes contain metals as well in greater percent weight by weight than your typical plastics that you come in contact with in your everyday life. But an interesting point.
Yeah, but are particles then anti-biofilm, anti-barnacle? Does that mean that they're less likely to have them, or does that mean that they attract them? It seems like they would repel them.
They should repel them for the anti-fouling coatings. Yeah. So that's their whole point is to keep them off of the boats. Yeah.
But I mean, for plastics that are not intended to be anti-fouling, but if plastic bottles fall into the ocean and start to degrade, just because of the polymer nature of plastics, are they naturally do they biofilms, or has anyone looked at that, or do they attract biofilms?
Yeah, no, that's a great question. So
the microplastics is very young and not a lot's known, but I just figured I'd ask.
Yeah, no, great question. So they're finding, and we did some work on this as well, that in terms of the plastics will have like a unique microbiome. So the microbiome isn't necessarily it's not the same thing as a biofilm necessarily, but it's the first bacteria to foul on a plastic, for example. So we did some work. There's others who have done this work as well before us, but just looking to see if plastic has a microbiome that's the same as the water surrounding it, or if you're on the beach, the same as the sand nearby, and so on. And what others have been finding is that plastic will have a unique microbiome that's totally different from the water surrounding it. And our work was done in the lab, so we were looking at 7 different plastic recycle categories, and we were incubating them and running seawater, because at the Duke Marine Lab, you're right by the water. You can just pump seawater into the lab, and measuring the microbiome. So I realized I didn't define that, the genetic makeup of the bacteria that are found on the plastic. And we monitored the microbiome over 70 days, and we're finding that even after 70 days, the plastics had distinct microbiomes from one another.
Most supplements are taken on faith and can take weeks or months to have an effect. Even supplements backed by scientific studies may or may not deliver those same benefits to you. But what if you could feel the results of what you took within just a few days? Lost Empire Herbs offers the highest quality, wild harvested, non-irradiated pine pollen, and that can dramatically impact your hormones fast. Right now, you can grab it for 1 cent plus shipping and handling at geniuspollen.com.
Oh, the different plastic types had different microbiomes?
Yeah.
Which were still different from the microbiome of the surrounding, sand or plants or whatever it may be in the body of water, right?
Yeah, so others have looked at the water surrounding. We were just looking to see if the recycling types were different in this study, but in the scientific literature, it's pretty well established that plastic has a different microbiome from the water surrounding it and often the sand. So I've seen the seawater study more frequently than sand.
Well, it makes sense. It's a different microenvironment, so a different bacteria would be able to take hold. I don't know if they're eating the plastic, but at least it's a home for certain ones that are able to adhere to different types of plastic. So I guess that's part of the reason why you get different microbiomes with different plastics.
Yeah. We did find bacteria that were associated with hydrocarbon degradation to be on the plastics. We weren't looking into there was no noticeable degradation, and we weren't looking into measure degradation either. But the type of bacteria have been found to be associated with hydrocarbon degradation. So oil spills, for example, which are hydrocarbons, and plastics themselves are hydrocarbons. So it makes sense. But yeah, it was interesting to know that the bacteria themselves must have been like sort of selecting the different plastic types, but that those microbiomes, you could tell the difference between one another. So yeah.
Yeah, I guess it's like a snail with a shell, or some kind of mollusk. If it finds a shell that'll fit it, it'll go in there. So, I mean, bacteria is a different mechanism, but if it finds a place it can hang out and exist and eat and not be killed, I guess it would hang out there preferentially.
Yeah.
So, I didn't mean to take you astray, but what is the focus of your research surrounding microplastics? Like, what kind of questions are you trying to answer?
Yeah. So my research is really interdisciplinary. I'm at the nexus of marine biology, environmental toxicology, as well as public policy. So I'm looking at how governments, businesses, and biologists mitigate plastic pollution. So my work has ranged. With a larger team at Duke, we've looked at how governments are responding to plastic pollution by looking at 2 decades of public policy responses. We've looked at how large companies are also committing to reduce plastic pollution in their sustainability reporting. And then, as you've heard already, I've done some work in the lab as well. And a lot of my work which we haven't talked about yet, but has been looking at plastic consumption in marine animals. And I use the sea anemone as my model animal. It's also a model animal for corals, but it's slightly easier to work with in the lab than corals directly.
Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button, and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up. And check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Oh, so these creatures inadvertently eat some of the microplastics, and then I would guess bad things happen to them biologically.
Yeah, so that's what we're looking at. Part of our questions are just around the feeding behavior. So why are they consuming plastic to begin with? And then, like you mentioned, some of the ecotoxicological consequences. So can they extract additives from plastic, for example?
You mean, are they preferentially extracting certain compounds from the plastic?
We don't know if they're preferentially extracting certain additives from the plastic, but can they even extract additives is sort of our starting question. So I'm not sure how much additives have come up on the podcast before. I know you all have discussed microplastics, but there's over 10,000 different additive or compounds that have been associated with plastic. Some of these are intentionally
like
additive.
Plasticizers, colors, all kinds of stuff, right?
Yeah, tons of stuff. And part of the reason they're there is just to make plastic, so useful, to make it soft and bendy and colorful. But when you are a scientist on the other side, you're starting to look and say, okay, there could be so many different, especially organic compounds in plastic. And some folks have reviewed them. We know that there's known endocrine disruptors, known compounds that can impair development, known and probable carcinogens, and also just a ton that we don't know anything about. So yeah, so we've started to look at additives, focusing on metallic additives first. I mean, metallic additives have known toxicological impacts already in the literature. Metals have been widely studied. So that's part of the reason we started there, as well as when you get into the organics, there's so many more options, I guess I would say, of different additives to look at.
Yeah, I guess so. Maybe you can consider plastic as like you have the polymer backbone, and then the additives are, I don't know how they interact with the backbone and stuff. And when plastic degrades, are the additives like, the least tightly bound and the most likely to decay and come off the plastic? Has anyone established that?
Yeah, so plastic additives are not molecularly bound to the polymer. So that's part of the reason that they leach out so readily. So that's, one of the key concerns from our lab about plastics is these additives that, can make their way out of plastic very readily, depending on the environment you're in, right? So whether that's an animal's stomach or in seawater, yeah, that's part of the reason that we're looking at them.
So what are you seeing so far with your sea anemone model animal? What happens, and what's the experiment look like? What do you see?
Yeah, so we're working with the sea anemone, as I mentioned, and part of the reason that we chose this animal, partly because I had already said it's a model animal for corals, but as well they don't have eyes to visually detect their prey. So they use a combination of physical stimuli and chemical stimuli in order to decide if they're going to eat something or not. So they have this great crown of tentacles, and when something comes into contact with their tentacles, they'll either guide it towards their mouth or they'll throw it away and decide not to eat it. So we've been, first off, just asking the basic question of, will plastic stimulate feeding in sea anemones, or will they ignore said plastic? Studies done in like the 1980s, not by our lab, but by others, have found that they won't eat things like a gelatin pellet, for example, and they'll move it away. So we were curious, will they even eat plastic to begin with? And we found that yes, all anemones that we tested consumed multiple plastic pellets. So pellets are just the pre-production pellets or nurdles that are the raw material to make all the different plastic items you use every day. And so first, yeah, we found that all anemones consume multiple plastic pellets. And then we were curious, so partly about the additives, but I can get back to that later because I want to talk about this other project that we've been working on. We were curious if plastic additives alone would stimulate feeding in sea anemones. So we basically took plastic pre-production pellets, plastic knives that were made from those pre-production pellets, and just very clean water. And we leached the pellets, we leached the knife into this water and kept some water with no plastic as our control. And then we took the plastic leachates and we placed them on little glass fiber filters. So they're just like filter paper, but made of glass, so no plastic. And we put a very small amount, just 7.5 microliters, onto these small glass fiber filters of the pellet leachate, the knife leachate, and then no plastic, just water. And interestingly, we found that with the plastic pellets, anemones that consumed the leachate 3.5 times longer than just the glass fiber filter alone. And the plastic knife, they consumed it for 4 times longer than the water alone. So when they consume something, they ingest it and it's retained in their gastrovascular cavity. And then when they decide they're done, they basically just spit it back out. So yeah, so we thought it was super interesting that basically they were thinking that glass with just plastic additives on it was food and significantly longer than just glass alone. So something in this plastic additive mixture, as well as there's physical stimuli as well, but something in this chemical stimuli, this complex mixture of plastic leachates is, stimulating the classics of taste in sea anemones. So we thought that was pretty fun and pretty interesting.
Yeah, but then what do you do with that? So what's the consequence to the anemone? Does it live less time? Does it look all messed up and grow tumors? Like, or is it totally fine? What happens to it?
Yeah, great question. So this was just at first a basic question, basic science, sort of asking the question of, will they eat it? We weren't doing long-term health studies, but they did not look any different at the end. I'll just state from my observations. What we're curious for the next step is, and this is going back to another study, but we're trying to see if they actually accumulate these different chemicals. And in this study, we're looking at, do they accumulate chemicals directly from plastic? And in our first study, we found that there were increased concentrations of lead in sea anemones that consumed polyethylene plastic pellets, high-density polyethylene plastic pellets daily for 12 days. And what that says to us, to get to your point, is that this could potentially be a new source of lead in the food chain, right? Which is, lead is well known to have impair development. It has known toxicological consequences. So we're starting there in terms of, do they actually bioaccumulate?
So you're saying that certain plastic, the food chain of animals, will bioaccumulate stuff that never normally would bioaccumulate, possibly.
Yeah, or that they might, coming into contact with metals, for example, and all these complex organic compounds from plastic in ways that they wouldn't necessarily in the environment if plastic weren't there, right? So there could be other sources of these various compounds in the environment, but plastic, it would be an additional stressor in the environment.
Right, but let's say I'm a fish that likes to nibble on anemones, and I'm nibbling on ones that have eaten microplastics. So they have a certain level of lead that's bioaccumulated in them. I eat an anemone, let's say. Now I got even more of it in my tissues. Then something else eats me. Then, a person eats that thing. So it may be a source of bioaccumulation where people may think, oh, well, these, tuna, for some reason, seem to be eating a lot of microplastics because they have a lot of lead in them. I'm just making this up. But maybe it actually comes from several levels down the food chain. And there's an accretion of this bioaccumulation of certain materials because maybe it starts at the lower end of life there.
Yeah, for sure. That's exactly what we're concerned about. And there's, billions of people who rely on seafood as their primary source of protein. So, yeah, so that's exactly what we are concerned about, Richard. Yeah.
Okay, I understand. I've asked everyone I've interviewed microplastics about this, and I really don't have much of an answer, but do you know anyone that is modeling as best they can? And I know the real world is different from lab model, but still, they could provide directional or order of magnitude information. But is anyone taking plastic bottles or other plastics and sloshing them around in a tank of salt water with a light source and maybe some sand and other things to see how fast they break down and what kind of constituent chemicals end up in the seawater around them? Anyone have a lab set up like that where they can start to get some data on this?
Yes, not exactly, but close. My colleague, Dr. Joanna Sipe, who recently graduated from Duke, this was what her dissertation was looking at from my point of view. She'll obviously explain it in more detail, and it's not, they don't have a beach set up necessarily, but she's looking at the fragmenting of plastic in order to characterize, the different sizes and shapes of microplastics that come off that are abraded. So I know they took a piece of rope found at the beach from the Duke Marine Lab, sent it up to Durham, where most of Duke University is based. The Marine Lab's in Beaufort, North Carolina, right on the water. So they sent it up to Durham, where Joanna was based, and they were looking at some weathering there. So yeah, I'd be happy to introduce you two so you can chat about that more.
Yeah, that'd be great. I think, also for you guys too, it may be a good thing to model to see what's going on, to look at, if you have an anemone in a tank and you put some plastics in there, after a day or two, what's in the water and what's in the anemone. Maybe you do another one for a week or two or a month and see what they're spitting out, what they're keeping, and how that's changing what's left of the plastic after they feed on it for a while.
Yeah, absolutely. Yeah. We haven't yet teamed up like that, but it'd be something that I'd be really interested in doing.
Yeah. Well, what other questions are you working on in your research?
Yeah, so as I mentioned, my work's super interdisciplinary, so we've also been looking at how governments are responding to plastic pollution and, reading a bunch of different public policies that have been adopted by governments over the last 20 years in order to address this issue. And
Well,
something
do
interesting.
governments, yeah, do governments perceive it as just like, oh, it doesn't look good type problem, like aesthetics? Or do they know about microplastics? Do they know about possible health impacts? Like, what do various governments know, and how has that shaped their policy?
Yeah, great question. So we've seen that most of the public policies that have been adopted, especially at the national level and subnational, so like your cities, states, and so on, a lot of those have been focused on plastic bags. And, we were looking at in this study about 291 different policies. We were finding that only 10 actually targeted microplastics. I believe it was 10. And only one targeted tire wear particles. So the microplastics created from tires and road friction. Yeah, so as you sort of alluded to, governments are really behind. Well, governments aren't targeting microplastics as much as the scientists are talking about them and that we're seeing in terms of reported pollution levels in the environment.
Okay. But again, are various governments aware of the magnitude of the problem, or do you see that they don't even perceive the problem and all the potential effects of it? Like, what are you hearing and what are you seeing in their policy? Like, what's missing, or is it pretty good, pretty inclusive, and they're capturing all the issues?
Yeah, the focus that we see on plastic bags, I think, really sums up that they're not, that, this, although I think it's really worthwhile to target plastic bags, I do think that, there's so many different plastic types surrounding us that those are just, the tip of the iceberg, I guess I would say. There's all the other single-use plastics, which still got some attention, but there's so much more to be done. Plastic bags just doesn't, just doesn't get to the heart of this issue. And I think, like, for me, I think the place to start is looking at plastics that can be avoided. So the UNEP calls it the unnecessary, what is it? Oh no, I'm forgetting, sorry.
That's okay. We can just edit that out, no problem.
Okay.
Yeah,
No.
no problem. Take a breather. If you remember, we can redo it. The answer. If not,
Oh,
we could just move on.
I do remember the
Okay.
problematic and unnecessary plastics. So those that, are either problematic due to their chemical additive content, for example, or they're unnecessary to begin with. So plastic bags is often one of them because we have a known replacement for them of just your reusable cloth bag, for example. Yeah, so there's a lot more to be done than plastic bags, I would say. That's not all that we saw, but seeing that that was so much of a highlight, I think really emphasizes that point.
Okay. So what other issues are jumping out at you that you're working on with plastics? Can you hear me okay?
Yeah, sorry. I was just trying to think about which part I want to talk about.
Oh, no
There's
problem.
so
No
many
problem.
different things going on in the plastic world. So, yeah, so something else that we've been looking at as well, and this study hasn't yet come out, but it's under review, so hopefully it should be out soon. But we've been looking at how large companies are responding to plastic pollution as well. And by large, we were looking specifically at those that are large by their annual revenue. So the top 300 on the Fortune Global 500. And we're reading through their different sustainability reports and trying to get at, one, are they even committing to reduce plastic pollution? And two, like, what types of plastic are they targeting? And, how does this, and what type of actions are they taking as well? So, and how does this align with what we know about the best available science? So that was a really interesting study, and I hope that we can share it soon. But in brief, we saw that there was a lot of focus on commitments involving increasing the recycled and recyclable content of plastics, as well as increasing recycling efforts as well. So increasing how much plastic we can recycle, and then in new plastic products, the percentage that is comprised of recycled or recyclable material. So, and the reason I find that interesting is that, globally, we've only been able to get at like a 9% recycling rate for mechanical recycling of plastic. So a little bit of what we're seeing companies commit to isn't exactly matching up with what has been shown to work for the majority of plastics.
Yeah, but also, too, if you have all these plasticizers and additives and all that, and you recycle a plastic, maybe now the structure and all the previous additives combined with new additives and, new polymerization may leave islands of, over-polymerized or islands of concentrations of certain additives that when the plastic starts to break down, maybe now it's more friable, maybe it exposes these aggregated, concentrated areas of either maybe deformed polymer or, again, other additives now that will preferentially leach out in great quantities. So I know recycling in some ways may be very good, but the quality of the product and the nature of it and how it breaks down may be unintended in a good or bad way.
Yeah, exactly. Sometimes that can be downcycling because the quality of the plastic is actually downgraded. Then it limits the ability for plastic to then be used oftentimes in food packaging, for example. So most of the food packaging, if not all of the food packaging that you see, most of it is your new pristine plastic and not recycled because of the reasons that you were just saying, Richard, that the quality is downgraded because there's all these different additives in plastic and different contaminants that are introduced during the recycling process as well. So it was interesting that we were seeing sort of this disconnect with what we know about recycling. And, that's one of the reasons that plastic isn't recycled. There's so many. I think we could have a whole podcast just on that. But, it's not designed from the start. Most plastic, at least, is not designed from the start to be recycled at end of life, partly because of the additives. And also economically, it can be really costly to undergo recycling. And it's often cheaper to produce new plastic instead of recycling the previous plastic. And the infrastructure is also limited as well, that, especially I'm based in the United States, but recycling infrastructure needs to be improved as well.
Right. But again, there may be the unintended consequences of, the more recycling that's done, maybe the lower quality, or maybe the quality is acceptable for the active use, but as it decays, maybe it's far worse for the environment, I'm just speculating, than virgin plastics. Who knows? I don't know if that's being explored, but it probably should because, recycling may have unintended negative consequences in ways we can never imagine.
Yeah, absolutely. There needs to be more work done on that. I agree as well. That reminded me, and recycling really is just delaying plastic disposal too. You can't be recycling infinitely. So for most plastics, at least. So I think it was since 1950, about 10% of plastics have been recycled. And then only 9% of that 10% has been recycled more than once, if I'm getting the exact percentages right.
So it's about 1%.
Yeah, or 9% of that 10%. So 1% of the total.
Yeah, 10, 0.1 times 0.1, 0.01, 1%. Yeah, sounds like.
I'll leave the mental math to you, but.
Oh, no problem.
Yeah, it's a very, very small amount that is actually recycled more than once. So in the end, we're just, delaying the issue of needing to dispose of this plastic in a way that is safe and doesn't make its way into the marine environment, for example, or other environments as well, like freshwater lakes, rivers, and so on, that then often drain into the ocean.
Oh, or what if you're able to embed a compound that if the outer layer of plastic wears away to a certain degree, this inner layer contains compounds that when combined with seawater or even fresh or brackish water accelerates its degradation. Maybe it turns maybe it degrades a lot faster, it degrades along a different profile. Maybe that would be something that may work because so much of this plastic is going to the environment. If it had a like a dead man's switch, essentially, where it kills itself faster somehow, or just associates faster. Maybe that's a solution.
It's a cool idea. I would ask, what does it degrade into?
Yeah, I don't know, but I'm not sure what could be done. I mean, there's a lot of heavy chemistry there, but it's an idea. Maybe one of the additives, again, deliberately would be something like that. That when it's exposed to certain environments, it radically accelerates the degradation.
Yeah. I think that would be really interesting. It's all about the environment it ends up in, right? So you'd have to control for factors, plastic, to go full circle to what we were talking about earlier, be, first getting some microbiome layer, then the biofilm, probably sinking into a different environment. So just at what point could you trigger some degradation? And then what does that environment look like? And how do you match that up is sort of where my brain is going. And then how do you account for things, rainfall and sunlight? And yeah, it's a really cool idea.
And also in terms of cleaning up certain environments, like, I'm in Austin, Texas, and, I've gone for walks with my wife, around various bodies of water, and there's all kinds of macroplastic floating in it. But what's the potential of a single macroplastic item to turn into millions or billions of microplastics? I don't know. So maybe like the 80-20 way of doing cleanup would be make sure you get rid of the macroplastics, because the longer they sit, the more they can, fracture into, again, thousands, millions, billions of microplastics. So numbers wise, maybe that's the best way you can kind of take a whack at the problem and reduce its severity.
Yeah, we've done some research on plastic cleanups as well, and looking at in this study, we were looking at what are the different cleanup technologies that are out there in order to clean up plastic pollution. And I completely agree with you. Like, we need to turn off the tap, right? We need to stop producing so much plastic that makes its way into the environment. But we know that by count, there's more microplastics out there than any other type of plastic. So we have way more microplastics out there for the reasons that you just said, that plastic's abrading, it's weathering, and even just during use, like opening plastic packaging produces a bunch of microplastics as well. So yeah, I do think we need to remediate some plastic pollution. We do need to and clean it up, but we do need to be careful about how we go about that in terms of, some of the methods out there if you're not cleaning up by hand and you're using these various technologies, there can be some unintended consequences. So collecting bycatch, for example. So sometimes you can interact with the animals that are out there if you're using big nets, for example, to capture plastic. Yeah. So
what a complicated problem. Right.
Yeah. So it's you do want to get it out there. It's just get the plastic out of the environment. It's just making sure you do that in a way that doesn't inadvertently harm the environment. And there's a lot of really interesting projects out there working on this, and that have also, I would add, just some added benefit of like education and outreach as well, and in terms of letting folks know about the issue. Thinking of like the Baltimore trash wheel, for example. I don't know if you've ever been there.
What is that?
Have you ever visited the Baltimore trash wheel?
Oh, no, it's a trash wheel or rail, or what is it?
It's a wheel, and they have now a series of different trash wheels. So I don't know the exact mechanics, but basically in the Baltimore Harbor, which is a really, beautiful area, and there's a lot of people walking around by the city in this area, and they have a trash wheel. So it's like a wheel that will spin around and collect trash that would be draining into the harbor otherwise. But they, I think, go above and beyond in a great way in terms of, and I'm not working with them or anything, but they, do fun things like they add googly eyes to the trash wheel and conduct a lot of education and outreach programs so people get to know more about like what trash they're collecting and how you can prevent this pollution to begin with and so on. So I think there's some added benefits to the plastic cleanup technologies as well.
Oh, it'd be like a trash monster or something, and kids can see it eating trash, or adults.
Yeah.
But, you don't want them to think like it's going to solve it for them, but it's just a interesting example of what could be done and what comes out of the water. I'm sure maybe they display, I guess, maybe they have exhibits where they display the stuff they pull out and the condition it's in. And they show you like, oh, every day we pull out 10 pounds of plastic. And I'm sure they can make like a whole museum out of the thing,
Yeah. Yeah. I don't know if they have exhibits, but I know they did do a lot of data collection around what are we finding in our trash wheel. So I think it's some fun efforts, and some worth efforts.
Yeah, I think also too, like if you have a body of water near you and there's visible plastic pollution in there, I mean, you could probably do a simple experiment where you go and sample the water, I don't know, every day for a week, get a baseline, and then every day for a month you go and pull trash and plastic out and see if it materially changes the concentration of various plastics and things in the water. That might be a somewhat simple, like directional order of magnitude experiment to see what the possibilities are.
Yeah, it's a cool idea. We're doing something.
I know you need funding to do all this. You can't do everything.
Yeah, no. I want to do everything. That's the problem. But one thing we are doing, it's not exactly what you said, but it's sort of similar. We have so the Duke Marine Lab is located right near the Rachel Carson Reserve. So it's like a little nature reserve in Beaufort, North Carolina. And we have sediment samples. Someone who was in the same lab that I'm in, who's now a professor at Wittenberg University, that she collected in, I want to say it was the 1980s, 1990s. And she stored them for years. She had extra samples from her experiment, so she's just kept them for years. So now we're going out into the Rachel Carson Reserve and, seeing if we can do an update basically of how have our microplastic levels in sediments changed over, how many decades has that been now? 4? Time is flying. But yeah, so over decades basically, in order to see, how are the numbers of microplastics that we're finding changing. We expect that they'll increase over time, given that the amount of pollution that we're generating is increasing over time. And then, what other patterns might we see? An increase in a certain type of plastic, increase of certain shape, for example, like maybe microfibers from our textiles. So we're still working on this study, no results that I can share at this point, but it's been fun to get that project started, and hopefully we can share results in coming years.
Yeah, excellent. Well, Zoe, what's the best way for people to find out more about your work? Where can they go?
Yeah, so I am on Twitter. It's my first and last name, Zoie, Z-O-I-E, last name D-I-A-N-A. And I have a website that shares some of the research that I've talked about today and more of my background. It's my first name, www.myfirstname.mylastname.com. Yeah, and I'm also around various Duke Marine Lab sites as well, so you can find me there.
Okay. Excellent. Well, Zoe, thanks so much for coming on the podcast. I really appreciate it.
Yeah, thank you so much for having me. I appreciate it.
Remember, before you go, to grab your 1 penny bag of pine pollen for all the amazing, all-natural hormonal support that men and women the world over are raving about. Try it out and see how it works for you. All you have to do is head to geniuspollen.com to grab your bag today. Within days, you may be able to notice greater energy, more focus, added recovery, and more. Again, please visit geniuspollen.com to learn more now. Thank you.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.